A few minutes here to start. Let's talk a little bit about the test format, what to expect. So this is all up in OneNote, so you don't really need to write any of this down if you don't want to, but like whatever you want to do is fine with me. So for the test, you'll have to be able to convert degrees to radians. One question doing that. One question going radians to degrees. You'll have one question where you have to calculate some arc lengths. I will not be providing the arc length formula, so you need to make sure you have that committed to memory, as is, of course, the conversion between radians to degrees. You'll have the one question where I ask you to find the perimeter of a sector. One question where I ask you to solve a right triangle. One question where I ask you to draw some standard position angles. Two questions where I ask you to find some exact values using the unit circle. One question where I'm going to give you a point on the terminal side of an angle and ask you to find the 6 trig ratios from that. One question where I'm going to give you one of the trig ratios and the sine of another and ask you to find a specific trig ratio. One question where I ask you to use the unit circle to evaluate an expression. So we had some of those in the review, like sine of 210 times tangent of 45 plus cosine of 300 or what, something like that. One question where I give you a parent function and a transformation. I ask you to describe that transformation in words. And then one question where I give you a parent function and several transformations, and I ask you to find that final, or the equation for the final transformed function. So that hopefully narrows down your studying a little bit, so you know pretty much exactly what you need to have. So just as from a memorization standpoint, you need the conversion factor between degrees and radians to degrees. You need those arc length formulas. There's like 2 versions. Hey, Joe, did you check in at the office?
Yeah.
Okay. And then you'll need the 3 different definitions we have for sine, cosine, and tangent. So you have the right triangle definition, SOHCAHTOA. Most of us probably already have that memorized. You have the point on the terminal side of a standard position angle definition. So like x over r, y over r, still basically SOHCAHTOA, just x is adjacent, y is opposite, and r is hypotenuse. And then you have the unit circle definition, which is basically the same as the standard position angle definition, except r is 1. So like x over r becomes just x, because x over 1 is just x, right? So those hopefully not too bad in terms of things to remember. There's not really that much from a memorization standpoint. If I'm you, I would focus on making sure I know how to do these specific kinds of problems and when to use which definition of sine, cosine, tangent, etc. Tends to be the trickiest part. Okay. Any questions about the test format or whatnot? Okie dokie. So last time in class, we gave you some time to work on the stuff from the problem set. Let's take a few minutes here and take questions. So if you have any questions specific to homework problems, or if you have any questions kind of in general to the content we've been talking about, any or all of those kinds of things is fine. Just taking questions. Mackenzie? Sure. Okay. So looking at number 4, so there's a couple of ways that I could go about doing this. It's asking me in this question to find the exact value using the unit circle. So I can do this either numerically or I can kind of do it visually. I'm going to do it kind of both ways for you just to kind of see. Numerically, what I'm going to want to do is find a angle, we're really both regardless. I'm going to want to find an angle that's coterminal to this. So if I'm doing it numerically, since this is a rather large number, it's probably easiest to use my calculator. In addition, it involves all these fractions, which are kind of a pain in the tuchus. So the easiest way to do this is to just kind of drop the pi's. To find an angle that's coterminal, I'm going to be adding or subtracting 2 pi. Since 58 pi over 3 is way bigger than 2 pi, I should be subtracting, because I need to get down to something in between 0 and 2 pi, so it's on the unit circle. So I'm just going to drop the pi's, and I'm going to do 58 over 3, and then I'm going to go minus 2. And I'm just going to keep subtracting 2 until I end up with a number that's between 0 and 2, and then I'll convert it back into a fraction.
Why do we subtract by 2 again?
To find an angle that's coterminal, you're going to be adding or subtracting 360, or if you're in radians, adding or subtracting 2 pi's.
I see.
So I'm just going to drop the pi's off so I can handle this on the calculator. If you leave the pi's on, the calculator doesn't know what to do when turning the number back into a fraction at the end. So I'm just going to ignore the pi parts.
Okay.
So I'm just going to subtract 2 a bunch of times. And there we go. So I'll convert that back into a fraction. So that's 4/3. So I know that this is really the same thing as cosecant of 4 pi over 3. Okay. So now I'm going to go to the unit circle, and I'm going to locate 4 pi over 3, which is right here. Cosecant, I remember, is the reciprocal of sine. So that's going to be 1 over y. So the y coordinate here is negative root 3 over 2. So 1 over y is going to be the reciprocal of that. So it's going to be negative 2 over root 3. And then if I rationalize my denominator by multiplying top and bottom by root 3, I end up with negative 2 root 3 over 3.
I kind of got lost when you said 1 over y.
Okay.
Where did we go back to the last circle?
It's not coming from that. That's something I have memorized.
Okay, so what is it? Like why would it?
So on the unit circle definition of sine is the y coordinate.
Okay. Oh, because it's sine, so we're just...
Cosecant is the reciprocal of sine, so it's 1 over y.
Okay. I got that.
Mackenzie?
So, when you're using the unit circle, is r, I guess, it always just 1?
Yes. Now, you could have also done this visually without your calculator. So if I convert 58 over 3, that's embarrassing, is 19 1/3. If you just kind of like, you do 3 divided by 58, you have like 19, like that. So what I'm going to do is I'm basically going to do count around the unit circle. So this is a half pi, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15.5, 16, 16.5, 17, 17.5, 18, 18.5, 19, and then a third more gets me right to here, to the same spot that we identified using our calculator. So either way of thinking about it is fine, whether you're finding the coterminal by just
Circles.
going around the unit circle visually, or whether you're going to use, add and subtract 2 pi's or add and subtract 3/60s. You're doing the same thing. Either way of coming about it is fine. It's really one way is not appreciably more difficult than the other. I think the calculator is probably a little bit quicker, but only if it's as many spins as that thing is. You know what I mean? Mackenzie, are you happy? Cool. Peyton.
On that same worksheet, can you do a one?
Sure. I think I need the other page. I only took one page of it, I think. Okay. So 11 asks us to find sine of theta, or find cosine theta, if sine of theta is 1/4 and tangent is negative. So on this, I'm going to use for these kinds of problems, I'm probably almost always going to be using the standard position angle definitions. So I remember that sine is y over r. So that tells me y should be 1 and r should be 4. Okay with that, Peyton? And I know tangent is y over x. And y I just discovered was 1. So if 1 over x is negative, that tells me just that x is negative. Okay with that? Okay. So now I'm going to draw my picture. So because x is negative and y is positive, I'm going to be over here in the second quadrant. Okay there? Okay. I'm going to draw my point and make my reference triangle. So I know the x side is negative, so I'm going to put a negative sign there. I know the y side is 1. And I know the hypotenuse is 4. So I'm just going to use the Pythagorean theorem then to find the length of that x side. So x squared plus 1 squared equals 4 squared. So x is going to just be the square root of 15. Okay with that?
Yeah.
Okay. Again, I skipped some steps, so if you know. And now that I have everything drawn, I can answer the question here. It's asking me to find cosine theta. So cosine theta is x over r. So that's negative root 15 over 4. Since I identified that point as negative root 15 comma 1. Is that okay? So again, the trickiest part really is getting that angle in the right position. But to do that, you can really just kind of default back to your or standard position angle definitions for sine, cosine, and tangent. And you should be able to reason out what quadrant it's in based on like, okay, what's positive and what's negative. It's usually not too difficult. Like this one was quite straightforward. And they don't get appreciably more difficult than that. Ava.
Hey, Can you do 54 on the ChatGPT problem?
Sure. Oops, that's chapter 3. Okay. So it says find the exact value using a reference triangle. Okay. So I'm going to start here first by drawing 5 pi over 3. So 0, this is pi over 2, that's pi, 3 pi over 2, and then back to 2 pi again. Okay with that, Ava?
Yeah, and is that just from the unit circle?
Yeah, well, it's basically every quadrant is 90 degrees.
Right.
90 degrees is the same as pi over 2.
Okay.
So every quadrant is just a half a pi.
Okay.
You could steal that from the unit circle, or you could just equate the two. Either is fine. So 5 pi over 3 is basically 1 2/3 pi, right? Is that okay?
Yeah.
Okay. So that's going to be somewhere over here then. Little bit more than 1.5. Cool so far?
Yeah.
Okay. So if that's the case, and I draw my reference triangle, I know that the y side is negative because we're in the 4th quadrant. Cool with that?
Mm-hmm.
And I know this angle here has to be pi over 3. Why is that? I've gone 5 pi over 3. All the way 1 full circle is 2 pi. So the difference between 2 pi and 5 pi over 3 is just pi over 3,
Okay.
right? I did 5/3 of a full turn. There's 1/3 left, right? If I convert that into degrees, that's 60 degrees. So what I'm looking to build here is my 30, 60, 90 triangle. Cool with that?
Yeah.
Okay. So opposite the 60 is I'm going to use A instead of X since we have X coordinates floating around here just to keep things from getting too confusing. So that side, the opposite the 60 is the A root 3. The side adjacent to the 60 is the A, and the hypotenuse is the 2A. So far, so good?
Yeah.
Okay. Then the last thing I need to do, I know that secant is hypotenuse over adjacent. So the hypotenuse in this case is 2A, and the adjacent side is A, so that should just be 2.
Okay, thank you.
You're welcome.
Could you further explain pi over 3 complex? Try to.
So this spot over here is 2 pi, right? How much more do I have to go to get to 2 pi if I've done 5/3 pi?
Oh, okay. So you're just like subtracting.
Yeah.
2.
Yep, exactly. So there's just 1/3 left, right?
I see.
Just doing some fraction arithmetic in my head.
Good.
Mackenzie. Okay, so page 3. Perfect. Let me pull that. And then you said number 8.
Letter A.
Letter A. Something with an sound in the. Now, you machine. I definitely hit copy there. Okay. So find the perimeter of a sector created by a 3.1 radian angle intersecting a circle of radius 18 inches, or 18.1 inches. So a sector is like a pizza slice, right? So these sides are R's, and this side is going to be an arc length, and that spots my theta. So my perimeter is going to just be the distance around. So that's R plus S. The R's we know are 18.1. The theta we know is 3.1. So all we need to do is calculate S. Since theta was in radians, I can use just S equals R theta. So 18.1 times 3.1. Is that okay? So I can just type this into my calculator. And it should be 92.31. Whatever inches I guess we're in. So you could do that, or you could do just use the degree formula. Where you just tack on that extra conversion factor to the formula. But it's really doing the same thing as converting the angle to radians and then plugging it into the other formula. Still the same thing, Mackenzie. How come nobody yelled at me for like, why did you type in 5.1 times 18.1? I have 1 times 18 plus 1 times 18 plus 3.1 times 18. So I add up the coefficients 1 plus 3.1. If this was 1x plus 3.1 x's, you'd write it as 5.1x, right? So that's all I did, just to save me some buttons on my calculator pushing. Promise it's the same thing as doing 18.1 plus 18.1 plus yada, yada, yada. Mackenzie, are you happy with that? Peyton.
Still on the review packet.
Sure.
On page 5, did you do question 6H?
Sure. So page 5, and then this one down here at H. Okay? So it just says to find two angles that are coterminal. So I'm just going to add 2 pi one time to get my first one. And then I'm going to add 2 pi 2 times to get the second one.
Or could you do one with plus 2 pi and the other one is subtracting?
Absolutely. Absolutely. Now, you could do that fraction addition by hand manually, but I'm going to just use my calculator to handle it. So again, to handle this, I'm just going to ignore the pi's. So I'm just going to do 7 pi over 3 plus 2. And then make that a fraction. So 13 pi over 3. And Evan, this is why I'm going to add 2 pi twice, is because typing into my calculator just is going to be less buttons, because I can just take my previous answer and add 2 to it. But there's nothing wrong with what you had suggested either. So when I do that, I get 19 pi over 3 for my other one. Peyton, are you happy with that?
Yeah.
Okay. So again, usually the worst part about that is just like dealing with the fractions, right? But it's no big deal. The calculator can handle a lot of that stuff for you if you know how to ask it politely. Mackenzie. Page 7. I'm going to need the unit circle for this. So let's go back and grab that. Okay. And which letter did you want again? C, you say? Okay. So my first order of business is going to be finding the things that are coterminal to negative 23 pi over 6 and positive 19 pi over 4. And I'm going to just do this numerically. So I'm going to take negative 23 pi over, or 23 over 6, and I'm just going to keep adding 2 to it until I get something that's between 0 and 1. So that's going to be the same thing as pi over 6. And then the same thing here with the tangent. So 19 pi over 4, I'm just going to write 19 over 4. And then I'm going to subtract 2 from that. So that gives me 0.75 or 3 pi over 4. So far, so good. Okay. So what's easiest for me is I'm just going to type in like the fraction and then press enter. And then I'll do plus 2. So I can just keep pressing enter after that. It'll just keep repeating the add 2. And then I can do math frac from there. Sometimes if you're not careful about like the order you're doing it, that fraction command won't work. Is that what you're running into, Mackenzie?
No, I just added pi.
Oh, yeah, I can't have the pi's in there for this to work. 0 and 2, right? Because you need the unit circle goes from 0 to 2 pi. So if we drop the pi's, you want between 0 and 2. If you did negative, what did that be, like negative 11 pi over 6, you'd have to go to the unit circle. Yes, you could, but you'd have to go and do that. Okay. And you'd end up at the right spot, but you'd have to be careful to make sure you're going clockwise instead of counterclockwise.
Okay, so because it's
I'd rather make sure everything is between 0 and 2 pi. That way you can just find it on the unit circle and I don't have to worry about which way am I spinning around. Does that make sense? Okay, so if I locate pi over 6 on my unit circle, there it is. Cosecant, I remember, is 1 over sine. And sine is y, so 1 over y. Oops. So the reciprocal of 1/2 is just 2. Tangent, I remember, is y over x. So if I locate 3 pi over 4, There it is. So y over x is just going to be -1. And 2 plus -1 is 1. Evan?
On worksheet 2, line number 7.
I still have a question.
Sure. Yeah, let's follow up and then we'll get right with Evan. Go ahead, Mackenzie.
Why is the 2 not negative?
So remember, if you're doing -11 pi over 6, you're going this direction. You're going clockwise. So you're ending here. The y-coordinate is positive,
Oh, okay.
right? That's the downside of using negative angle, is because it's very tempting to grab this one at 11 pi over 6, but that's positive 11 pi over 6, which is, you get what I'm saying? Okay. So Evan, worksheet 2, number 7, is that what you asked for?
Yes.
Okay. So I'm going to start just by remembering that my general transformation is written in this form. So horizontal stretch, that's an H value. Vertical shift is a K value. Reflect over the y-axis is a C, and that's going to be -1 since there's no stretch associated with it also. And then horizontal shift, horizontal stretch, E for jeepers, that's a C value. Horizontal shift is an H value. Yikey shnikes. So far, so good. Okay. So what I'm going to do this in 4 steps. So my first transformation is going to be f of 1 over 2x. Since in that first step, h is 1, a is 1, and k is, or a is 1, h is 0, and k is 0. Everything else just kind of drops off, and all I have is that 1 over c in there, right?
Yeah, but C is 2, but it's also -1.
Right.
So just be able to
We need to make sure we're doing it in order. So we're going to do the stretch first, then we're going to do the next thing, and then we'll do the flip. So it has to be done in order based on the directions. Is that okay?
Yeah.
Okay. So if I go to f of 1/2 means I'm going to plug 1/2 in for x. I'm sorry, f of 1/2 x means I'm going to plug in 1/2 x in for x everywhere I see it. So 1/2 x squared is 1/2 x times 1/2 x, or 1/4 x squared.
That's so lost.
I'm just talking about,
Yeah, where is it on the
It seems to.
so no, the function
Oh.
is given to us in the problem, right? So I'm just plugging 1/2 x into that function. Is that okay?
Yeah.
Okay. To evaluate that down, 1/2 x squared is 1/2 x times 1/2 x, or 1/4 x squared. 2 times 1/4 x squared is going to just be 1/2 x squared. 3 times 1/2 x is 3x, or 3 over 2x. And I still have the plus 1 at the end. Is that okay for step 1?
Yeah.
Okay. For step 2 now, I'm going to take the previous step, but now I have a k attached to it, so it just has a plus 1 at the end. So all I'm going to do is add 1 to that previous answer. So it just becomes a +2 at the end now. No big deal. For part C, I'm going to take the previous function and I'm going to plug negative x into it, since C is -1. So negative x squared is still x squared. Negative and a negative is a positive, and then still the +2. And then my last step, previous step, but I'm going to plug in x minus 2. Is everybody still doing okay? So when I do that, I'm going to replace all my x's with x minus 2's. I'm going to have to FOIL out that x minus 2 squared. I'm just going to do that in my head, though. I'm going to distribute through the 3/2 x. I'm going to distribute through the 1/2. And when I combine all my like terms, I have 1/2 x minus 1/2 x plus 1.
Is there going to be a question like this on the test?
Yes, sir.
That's a lot.
Well, there's a lot of steps to handle.
Yes, a lot of steps that I could mess up on.
Unfortunately. Peyton.
I know that there's like online video on like to do like homework.
52? Sure. I think we already have that page, so I'm just going to scroll up to find it. There it is. Okay. So 7 pi over 6. Again, I'm going to remember 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi again. So 7 pi over 6 is basically 1 1/6 pi. So I'm going to go 1 pi and then like a 1/6 more. Cool with how I drew that, Peyton? Sure. 7 pi over 6 is 1 1/6, right? 1, so I did 1 pi to the horizontal, and then a 1/6 more, so just a little bit below the horizontal. Does that feel okay? All right. Let's make our triangle. And this angle, I know, is pi over 6. How do I know that?
It's just 1 pi, but it's 1 times pi is pi. And you subtracted, or you took out the 1, so you're going 1/6 over, so it'd be 1 over 6.
Okay, because I already did 1 pi to the horizontal, and then I did 1/6 more to get down to the angle, right? Is that okay? Peyton?
Yeah.
Okay. So I'm just going to convert that into degrees. So that's 30 degrees. So what I have is a 30, 60, 90 triangle. Now, since I'm in quadrant 3, I know that the x side and the y side are both going to be negative. So for a 30, 60, 90 triangle, this side is a root 3, this side is a, and that side is 2a. Still doing okay, Peyton? Okay. Do you need me to hold on for a second?
I just feel like lost.
Okay. Well, let's go back to where you weren't lost.
It's okay. I get okay. I feel I'm getting.
Okay. Yeah, if you just need a second, that's okay. Just be like, hey, can we just pause for a second? I just need to process. That's okay. So tangent is opposite over hypotenuse. So in this case, the opposite is negative a, and the hypotenuse is 2a. That's not what a tangent is. It's opposite over adjacent. So the opposite in this case is negative a, and the adjacent is negative a root 3. That reduces down to just 1 over root 3. And when I rationalize my denominator, I end up with root 3 over 3. Peyton, are you okay to there?
Yeah.
So usually the tough part is getting the thing drawn in the right quadrant, right? That tends to be really across the board for most of these problems. Is the hardest part, is just making sure you have the thing drawn in the right quadrant. And then from there, like the sine, cosine, tangent of it is usually pretty straightforward. But you just need to make sure you're going slow and getting the thing in the right quadrant.
Yeah.
You know? Or getting your picture drawn correctly. Mackenzie?
I have a worksheet, 2 page
Okay.
so I guess
Worksheet 2, page, oh, I have worksheet. I was like, that's not the right thing.
I just get confused. I don't know.
I see where you're getting confused already. Hold on. Yep, I see already what the issue is. We can do this though. Okay, so the thing we have to keep in mind is that this is, I got to get it into this form before I can identify the values for really mostly C and H are the two problem ones. A and K are going to be fine, even if I don't really rearrange things. But the H and the C are going to be a problem if I don't get into that form first. So I'm going to start by writing this as, well, let's start by factoring the 3/4 out. Notice that this coefficient has to be factored out. So if I factor 3/4 out of that, I'm going to need to divide 6 by 3/4, right? That's the same thing as multiplying by 4/3, which is going to be 8. Okay with that, Mackenzie? Okay. And now I know that 3/4 I need to write as a 1 over something. So 3/4 would be 1 over its reciprocal. So A should be 3, C should be 4/3, h should be negative 8, and k should be negative 1/2. If I look at the general form, it's 1 over c. So I'm just writing it so that my thing here matches up the same form. So I have to write it as 1 over c. So this number out here is my 1 over c. So 1 over 4/3 is 3/4. But the c value is the 4/3. Right? The c is always going to be the reciprocal of that coefficient. Right? Because that's the way it's written here. The coefficient is 1 over c. So c is the reciprocal of the coefficient. Does that feel okay? So the place where most people are going to make their mistakes is forgetting to factor this out and getting the wrong h. I think almost everybody made that mistake on the first test. Do you think you'll see that again on this one?
Probably.
Oh yeah, probably is a good answer there. So don't forget to factor before you look for those h's. I think almost everybody got the AK and C right. Most of us missed the H.
So all you do is just like factor it out when it's being squared. You just factor.
Yeah, whatever the coefficient on your x inside of the function has to be 1, so you have to factor that. Yeah, so 2 is going to be very much the same thing, right? So I'm going to start by factoring out the 1/2. So 1/2 or 2 divided by 1/2 is the same thing as 4. And since I look here, if I look at that leading that coefficient now, that coefficient is 1/2. So it's already written as a 1 over c. So I'm good. I don't have to do anything to the c value. So the a is -2, the c is +2, the h is -4, and the k is 0. Mackenzie, are you feel okay with that one? A little bit easier to see the c there because you didn't have to make a reciprocal or anything. I'm sorry, you're talking in the mask and being far away and looking down and all combined to just hear wah, 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 wah. Yes. Yes. Alexis, is there a follow-up to this one before I move to a different question?
No, I have another question.
Okay. So I'll deal with Peyton's and I'll come back and get you. Remind me not to forget you though, okay? So you said 13 here or something?
Yeah.
Okay. Did I have this one already? Oh yeah, I did. Okay, don't even need to copy it in. Okay. So cotangent is x over y. That's my standard position definition. So here I'm at a little bit of a loss, right? Because if x over y is -4/3, well, x could be negative and y positive, or x could be positive and then y could be negative. But I know sine, which is y over r, is negative. And the r is a length, so it can only be positive. So that just tells me that y is negative. So the one that I want is this situation where the y is negative. So remember, when we're talking about this, this standard position angle definition for sine, cosine, and tangent, x and y are representing coordinates. Those can be positive or negative. The r is representing the distance from the point to the origin. That's a distance. That always is positive, right? So that's how I knew that the r was always positive. So y over r meant being negative means that y is negative. Does that feel okay?
Yeah.
Okay. So I know how to draw my picture then. So I need to be in the first quadrant where x is positive and y is negative. So there's my theta. And if I build my triangle, I know that x is 4, y is negative 3. And if I use my Pythagorean theorem, I know that r has got to be 5. So cosecant theta, I know is r over y. So that's going to be 5 over negative 3, or you can just call it negative 5/3. Does that feel okay, Peyton? Okay. So again, like once you have the thing in the right spot, you know, it's like right triangle, Pythagorean theorem, like, and then a definition. The tricky part is just getting that, you know, sorting out what quadrant you're working in, right? Alexis.
Can you do number 5 on worksheet number 2?
Sure. Let's see, do I have that one? That's the view, that's the view. That's that one. No. Okay. Okay, so the key here is I'm going to be using this to transform my points from F into its transformation. So looking at this right here, A is negative 1, C is just 1, H is negative 1, and K is 2. We okay with how I came up with those?
Yeah.
Okay. So in this case, my transformation is is x minus 1, negative y plus 2. Cool? I just plugged in the values into cx plus h and ay plus k.
Oh.
Right, that we just got from over there. And now I'm going to use that transformation on my points in my function. So let's see, I have negative 3, 3, I have 1, 0, I have 1, 3, 3, 2, and 4, 0. Okay. So negative 3 minus 1 is negative 4. Negative 3 plus 1 is negative 1. You okay with what I did there, Alex?
Yeah.
Okay. 1 minus 1 is 0, and then 0 plus 2 is 2. 1 minus 1 is 0. Negative 3 plus 2 is negative 1. 3 minus 1 is 2. negative 2 plus 2 is 0. 4 minus 1 is 3. And 0 plus 2 is 2. So now that I have that, I'm just going to go back to my picture. There's negative 4, negative 1. There's 0, 2. There's well, that's negative 1, 0. Oopsie-doopsies. Makes a heck of a lot more sense. There's negative 0, negative 1, 2, 0, and then 3, 2. So it's going to look like that. Does that feel okay?
Yeah, I'm just confused about how you got like x minus 1 and y minus y plus 2.
Oh, okay. So my a is negative 1. Negative 1 times y is just negative y. And my k is 2, so just plus 2.
Then like you would take like the y value, the y in from the y there.
Right, so when for the first point, I'm plugging 3 in for y, so I have negative 3 plus 2 gives me the negative 1.
And then do the same thing for the x, right?
Exactly, yes. Yep. So I'm just plugging them into that little map that I've made, the coordinates, and finding the new coordinate. So the hard part is writing the map, but from there it's just like kind of pluggy and chuggy, right?
Okay, yeah, I was just confused on how you, like the formula.
Cool. Feel better?
Yeah.
Evan?
Can you do number 14 on worksheet?
Sure. I think I have these already somewhere. Okay. So cosine theta is x over r. And I know the r has to be positive. So I know the x has to be a negative 2 and the r has to be 5. Feel okay there? Well, it's because,
No, I got it.
okay. And then cosecant is r over y. Again, the r has to be positive, so I know the y has to be positive. Okay with that? Yes or no, Ev?
Yeah.
Okay. So I have a negative x and a positive y. So that means we're in quadrant 2. So I'll draw my triangle. So the x side is negative 2, and then the r side is 5. So using the Pythagorean theorem, I get that y is the square root of 21. Okay, so my point here is negative 2 comma root 21. Cotangent is x over y. So that's negative 2 over root 21. And then to rationalize my denominator, I end up with negative 2 root 21 over 21. And I'm done.
Oh, I get it.
Max, did you have a hand? Oh. Sienna? 50? Okay. Have that somewhere already, I think. Okay. So it just asks between the given intervals for theta, whether sine, cosine, tangent is positive or negative. So let's draw ourselves a picture here, figure out what quadrant we're talking about. So remember, these are 0, pi over 2, pi, 3 pi over 2, and back to 2 pi again. So to 4 pi, half, 1, 1.5, 2, 2.5, 3, 3.5, 4, and then 4.5. We're looking at quadrant 1. Which is both x and y are positive. Cool with that? In that case, I know that sine being y over r would be positive over positive, so positive. Cosine is x over r, positive over positive is positive. And tangent is y over x, positive over positive is positive. So they're all positive. That's it. Alexis?
Can you remember G on the review?
What page?
6.
What's up, Paul?
Like you really don't need to look at the y value then?
No, I needed the x values at times also, depending on which function I was looking at.
Okay.
Yes.
I'm confused on number 15 on worksheet 1.
Okay, so Alexis has a question right now, but I'm happy to come back and get you in a second. Okay, so you said which letter now, Alexis? G, okay. So secant of negative 225. So probably what I would do is I would add 360 to that so that it's in the unit circle. So really I'm talking about cosine or secant of positive 135. So on the unit circle, I find 135 degrees, which is there. Secant, I remember, is the reciprocal of cosine, and cosine is x, so really I'm looking at 1 over x. So here I have the reciprocal of negative root 2 over 2, so that would be negative 2 over root 2. And I rationalize my denominator, and I end up with negative 2 root 2 over 2. The 2's cancel. And I'm left with just negative root 2.
Okay, because if I skip a part, would you put like -2 root 2? So I must be confused in my head.
No problem. Paul?
So it's not one of the sine, cosine, or tangent. You're gonna have to do the reciprocal for the other. So it would be
Well, sine is, or cosecant is the reciprocal of sine.
Yeah.
Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent.
so like
But tangent was y over x. I would just do x over r, and I wouldn't bother with like thinking about it as a reciprocal per
that's all you
se.
do, just switch it.
Yeah. Really, I'm only going to worry about the reciprocal when the numerator is 1, because then I'm just going to take whatever I had and flip it.
Okay.
But if you have two fractions anyways, like, there's still fraction over fraction. You still have to deal with that. Okay, Evan, what is?
I
Oh, okay. All right. Can you guys clear your desks other than something to write within your calculator?